Hello everyone. In today's video, I'm going to introduce to you the 5 golden rules of debugging in Java. Hopefully these rules will help to save you tens of hours on your assignments and projects throughout the semester. I know that it does for me whenever I'm working on a big project or anything in Java. We covered this in the Java Bootcamp, but I wanted to make it available to everybody because I think it is so useful, and it's a shame that we don't have time to cover it in more detail during our labs. I've included a summary of this video up on Piazza with some details on all the 5 golden rules, but I also wanted to provide this walkthrough video so that in case you wanted a visualization of what we're talking about within those rules, you can have one. So first things first, I'm going to open up a new project in our IntelliJ IDE. This project is going to, or the example project I'm going to do today is just the solutions to your Lab 3. So that's singly linked list generic implementation. I've included the solutions almost verbatim, but I've made a couple of errors, and I'm going to show you how to best go about debugging those errors, or at least how to follow the 5 rules when doing so. So the first rule is all about setting up your configuration properly so that IntelliJ can assist you in debugging. For those of you who don't know yet, Java is a very opinionated language, and all of the tools and everything in the ecosystem is kind of designed around specific opinions about the way you should set up your development environment. And one of those opinions is how to set up your directory structure. We've covered this in a previous video, but I want to cover it just one more time since it is so important. In every project that you have, you want to have 3 different folders. You want to have an out folder, a source folder, and a test folder. You need to register those folders with your IDE. Registering your output folder is as simple as going to your project structure and pointing to it here. For your source and test folders, you'll come down here and you'll mark them as the source and test folder respectively. Additionally, every class should have its own file within the source directory, and every class should also have a corresponding test class in the test directory. So you'll notice singly linked list is in a singly linked list.java file, and the test for that is in a singly linked list test file. And that's all there is to golden rule number 1, but it can be a little bit confusing when you're setting it up for the first time, so I wanted to cover it here in this video. The second thing is still configuration oriented, but is something that you guys might not have thought about yet, and that's the difference between asserts and a test suite. So I'm going to be a little bit radical here, and I'm going to say that in general, it is never, ever, ever a good idea to use asserts over a test suite. There's a lot of different problems with asserts. One, you end up mixing up your source code and test code, and it can be confusing to differentiate between the two. 2, if you're using asserts can go anywhere in your code, right? And so if you've put them in your methods, or even if you aggregate them all in a main method, not having all of your tests in one convenient file, or in one separate file, can lead to some confusion. Additionally, if you don't explicitly come up here to your configurations and add the -EA options for enable asserts, your asserts won't even run. A lot of students forget this and think that they're passing all their tests when in fact they haven't even activated their tests in the first place. So that can be a little bit confusing, a confusing part of asserts. Additionally, the asserts don't integrate well with an IDE, right? So with our test suite, we get a nice user interface here at the bottom. You guys are probably familiar with this by now, and we can see, what parts of our code are doing well, what parts aren't, and we can get kind of some immediate feedback there. And then finally, asserts throw assert exceptions, meaning that if we don't wrap them in a try-catch block, anytime an assert fails, we will end up halting the execution of our program right there at that point in time. And so we don't get a very holistic perspective of how well our program is doing with respect to the tests that we've written, because we only go up to the point where our first test fails. With a test suite, even if one test fails, we'll still get to run the other tests, so we will get a more holistic perspective about the integrity of the code that we've written. And so that's why I'd recommend kind of ditching asserts altogether and going with the test suite. Now, a couple of notes on that. I know that we do distribute some files that have asserts in them, and I think it's great practice to take those asserts and refactor them into a test suite. That's obviously the best practice that I'm recommending with these golden rules, and also it gives you some experience and familiarity with the test suite interface. In particular, in this class, we use the JUnit 4 interface. Now, you might be saying, but asserts are so easy, right? It's just the one keyword and then a Boolean after. A test suite can be a little bit more daunting, right? We've got these imports up here. We've got this kind of cryptic import static. I've got to make sure to annotate everything with the @test stuff, and there's a lot more configuration options that we can get into. And so, what if I don't remember how to do it? Or do I need to actually Google or reopen old test files in order to see the template? And the answer is no. So in fact, if we just come to our singly linked list class, or really any class that we want to build a test suite for, all we have to do is click on the class name, press Alt-Enter to drop down this dialog, and then we click Create Test. And then we get this nice graphical user interface for building the test suite. So we don't really have to remember anything other than Alt-Enter on whatever classes we want to test. So obviously we select JUnit 4, we want it to be a singly linked list test, and then we want to, we can add whatever we want here. So let's say add and get. I want to add those to the test suite. It'll even recognize when we've already created a test suite, and it'll ask if we want to update it, and yep, we want to update it. And see here, we've got our 2 new tests added. And if we didn't have this test file at all, it would have generated this test file for us with all of these imports and everything we would have needed to be successful from there. So really, there shouldn't be any obstacles obstacles in between you and doing this correct test suite configuration. And setting all of this up, both with your directory structure and with the test suite, enables you to do some really cool things in the next golden rules, which I'll talk about here in a second. But before I do, I want to show you just kind of the generic output from a test suite in case you haven't already seen it. So if you come to your test suite and you just do run your test, you'll get something like this at the bottom where it'll show you we passed the 2-string test trivially since there was nothing in it, but we threw an error in our remove test. So something about a remove function wasn't correct. And so this will be kind of the default output that you get from your tests. Now to the third rule, and that's don't print run the debugger. So if we end up in a situation like we see right here where a remove test isn't working, we get this null pointer exception. Kind of our default intuition is, okay, let's see where the error occurs. In this case, we can click the hyperlink right here, and it occurs in this line. So let's just start printing out things, right? So we'll print out p, we might print out p.next, we might print out I and ants, and we've got all these like system.out prints littering our code base, and then littering our terminal because our output gets all jumbled, so then we'll need to label things. It just kind of turns into a big hassle. And so that's why I recommend never, ever, ever print out things when you're debugging in Java, especially if you've got something as powerful as the IntelliJ IDE. Instead, all you have to do is click, just normal left click, the line number that's throwing your error, and you get this little red stop sign. And what that's saying is, okay, when I'm trying to debug this code in our next execution run, stop the program right here and give me a view of all of the variables in the environment. And so that's kind of like a system.out print on steroids. And let me show you how we can do it. So we just come back here to our remove test, and notice that we've got these additional dialog buttons here. What we want is this debug remove. And if I click here and we run it, okay, notice we're back to this line number. The program has stopped, and now I can see all of the variables that are in the environment. So I've got, my p is a singly linked list node. This is a singly linked list. I is -1. And lo and behold, we've got this p.next is null, meaning that p.next.data, which is the thing that we're calling right here, will throw a null pointer exception. So this is cool. We've already figured out exactly where the error is occurring, and we can go in and fix it. But there's some additional things that you might want, or that you can do with this debugger dialog as well. So let's say, for example, we also want to know what the variable n was. So the debugger kind of has this, makes its best guess about what variables you want to see. But you can also manually add new variables just by clicking this plus button right here. So if I want to know what n is, all I have to do is type in n and enter, and it'll tell me exactly what the variable is in the context. I don't need to rerun anything. I can just use this interactive kind of explorer right here to figure out what it is. And with objects, it's even cooler. So for example, this is obviously referring to this object. And if I drop it down, I can see the different data properties in it. So I can see the head and n in here. Head itself is an object, so I can explore that object. I know that head is a singly linked list node, so it's got some data. It also has a next, and so I can click its next, and so on and so forth. So you can use this thing to explore these sort of nested object structures. Additionally, so let's say I want to set another breakpoint here at this while loop. What I can do is rerun the debugger. If I click the debug button up here. And so now we're back stopped at this while loop on line 81. I can actually run through the code step by step and see the variables in the environment change in real time. So I just do this little next step button, and now I'm inside the while loop. Notice my I has decreased by 1. It went from 2 to 1. And then it'll go back up because it's a loop. And then it'll go down. Notice now that I is 0. We go back up. And then we go back down, I is -1, and we're back at this kind of null pointer exception stop point. So this is a super cool way to get really detailed knowledge about, what the state of your program is at any point, and you can step through everything manually. Now, let's say that our while loop had something like 1,000,000 iterations or something like that, and we just wanted to see what the state of our program was on the second to last iteration. Obviously, breaking on a line isn't going to work, and stepping through 999,000 different loops or iterations of a loop is going to be super tedious. So what you can actually do is you can set a conditional breakpoint. So after I add the breakpoint here with the left click, the little stop sign, I can right click on it and I can see this condition. And now you can just put any boolean in here that you want. So for example, if I wanted to break it when I is equal to 999,999, that's all I need to do. And now the program will only stop and give you this dialog when this condition is met. So it's another cool way to get a little bit more utility out of the debugger in case it doesn't meet your exact needs just by breaking on a particular line. So there's so much more power in this that we wouldn't have time to cover it all in this video. But just with these tools that I've shown you right here, you can save yourself a ton of time throughout the semester. And I'd encourage you to explore this deeper and figure out some of the other cool utilities that are available here as well. So I'm going to go ahead and remove them just by left-clicking on them again. And I'm going to show you how to implement our fourth golden rule, which is making sure that you have 100% code coverage. So for those of you guys who are not familiar with the term code coverage, all that means is that our tests cover specific lines of our code. So our remove test is supposed to cover, obviously, our remove method. We want to make sure it has 100% coverage, meaning that it covers every single line in the remove method. If we don't cover every single line, that means our tests are probably incomplete because we haven't considered some of the cases for how the program executes. And so a lot of students have been running into this problem of, it passes the test suite that we give you, but not the test suite on AutoLab. And what usually is the case is that we only give you about half the tests that we put on AutoLab, meaning that we expect you to be able to develop some of the tests on your own. And so even if your thing passes, the half of the tests that we give you, if you don't have 100% code coverage, or if you haven't developed additional tests to get you to 100% code coverage, you're likely going to fail some of the edge cases that we put up on the AutoLab server. So I'm going to show you I'm going to show you a way so that you can real quickly and easily determine whether you have 100% code coverage. So if we just come back to our remove method right here, all I have to do is choose this option down here, which is run our remove with coverage. So if I click this right here, okay, I can see that, it pulls up this dialog here on the right, and it gives me some summary statistics. So it says that my singly linked list is 100% covered in terms of classes, but only halfway covered in terms of methods, and only 39% covered in terms of lines. So that's nice, kind of like as an aggregate viewpoint, but it doesn't give us all of the information that we might want to see in terms of what lines are specifically covered versus what lines aren't. Now, if we come back to our class, though, our singularly class itself, we can see these new green and red vertical bars. Green means we're good. Green means we're covered. But if you have a red bar next to any of your lines, that means that that line was never run during the execution of your test suite. So, for example, here, I've clearly not tested it with an input of I less than 0 or an I greater than size. So it's never throwing this new index out of bounds exception. Additionally, we have a red bar down here because anytime our program gets to this point, this ants equals p.next.data, we get that null pointer exception. The program terminates without ever coming to this p.next equals p.next.next line. So that's a good way to make sure that you have 100%. Or this is a good tool to give you hints about what new tests you might need to write in order to get 100% coverage. Now, a quick caveat with this is that even if you have 100% coverage, that's not necessarily the golden standard. It's just a rule of thumb. If you don't have 100% coverage, you're not doing something right. But if you have 100% coverage, it doesn't necessarily mean that you've done everything right. For example, there are many different ways that we can reach this line of code. And unless we test every single, class or category of ways that we can get there, so think about edge cases and other stuff like that, we haven't really fully tested this method. But the code coverage is definitely a good starting point, and if you don't have 100% code coverage, you're definitely not doing something correctly. So making sure that you have 100% code coverage and using the code coverage tool in IntelliJ is invaluable in catching those things that you might have forgotten, like this particular index out of bounds exception right here. Okay, so that was basically everything that I wanted to show you within the IntelliJ IDE itself. But the fifth rule is still super important, and that's using the Java docs. So kind of my dirty confession is that for most of the classes in Java, I have absolutely no idea what they do or how they work. But I know that within seconds I can figure out, exactly how to use it, what the time complexity of the different operations are, what the operations within the class even do, just by going to the Java docs. So if I come up here and open up my web browser, maybe, yep, here we go. All I have to do to know, let's say, for example, we're going to talk about hash maps later in the semester. And so if I'm not familiar with how the default implementation of hash maps in Java works, all I have to do is do Java 8 hash map. And then you want to click this docs.oracle link right here. So these are the Java docs that will give you the detailed information about what you can see. And I won't go through everything here. But by just reading these couple of paragraphs about how the hash map works, you can get some really invaluable information about where a hash map might be useful, the complexity, the time and space complexity about some of the different operations, as well as if you scroll down here, you can see all of the different operations you can perform on a hash map or with a hash map and what exactly they do. And so this is kind of the default place that I go. You can almost solve any problem in this course just by coming to Google, Googling your Java 8, and then whatever class or even language construct like for loop or enhanced for loop or something like that, and then go to the Java docs. That would be the very first place I would look if I was running into a problem. And I often turn here because there's so much stuff in Java. It's one of the largest languages out there. That it's just impossible to keep it all in your head. And so having this reference at your fingertips is absolutely invaluable. So that's all I had to share with you guys today. As a reminder, all of the stuff that I covered in this video is summarized here on Piazza. Additionally, if you have any questions or follow-ups, you can always reach out to me, or even better, posting a question here on Piazza where anybody can answer it, and everyone in the class can see the answer and hopefully benefit from it. So thanks for watching, and I hope this helps you save some significant time in your C343 semester.